To Curtin University and the CM2 research team. It is my pleasure this morning to demonstrate to you how the UV spectrophotometry technique could be used as an alternative to gel chromatography or HPLC method of detecting furan in transformer oil samples. Let me introduce to you the research team that is responsible for conducting this research at Curtin. Starting from my left, from my right is Dr. Narottam Das, and he is a research fellow appointed through CRC2 project. We have Dr. Ahmed Abu-Siada, and he is a senior lecturer at the Department of Electrical and Computer Engineering at Curtin, who is a key investigator in this research. And finally, my name is Syed Islam, and I'm a professor of electrical engineering and have been involved as the project leader for the Curtin node for CM1 and CM2. So without further ado, we will take you now through the demonstration process to demonstrate the furan estimation method.
Thanks, Syed. As you can see here, this is our setup. The light sources here, we have two light sources, and they have various range of wavelength. That's ultraviolet and infrared here source. They are connected through fiber optics here to the sample. We have a cavity holder where we insert the oil sample inside here, and then the light will interact with the sample, and then the output will be transferred to the spectrophotometry here through another fiber optics, where it will be analyzed inside, and depends on the measurement type, whether it will be absorbance or reflection or radiation test. We are concentrating at this stage on absorbance test. It will be analyzed here, and then will be transferred to the software here, where we will get here the spectral response of the oil sample. What we are doing here, we are collecting oil samples, as you can see here, with different furan contents. These furan are measured using in extra lab, so we know the furan amount in these oil samples, and then we analyze it using the spectral response here. And we could find a good correlation between the spectral response and the furan contents. We found this relation through two softwares, fuzzy logic software and gene expression programming. So we have now a mathematical relationship between furan and the spectral response parameters. So I will go through the test procedure. The first step in the test is taking a dark reference signal. So what I will do now, I will block the light. The light here is blocked, is not on. And if I go to the software here, I have to take a dark reference. Now the dark reference is stored inside. The second step is to start our light here. We can use either of the sources because we are interested only in a range of like 500 nanometer, and both of them are capable to provide us with this range, so we can use any of them. We can take our light reference. We can now extract our sample. 25 millimeter is enough for the test. And because this test is sensitive for temperature, we ran this test under different ambient temperature, like from 20 degrees to 25 degrees, and we found the impact of the temperature on the test. And this has been taken into account in the software we developed. So this is the absorbance here, and we repeated this test for various furan contents in oil samples, and we found that there is no overlapping either in the bandwidth here, the intersection with x-axis, or with the maximum absorbance. And then we used these two parameters, the bandwidth and the maximum absorbance, as two parameters for our fuzzy logic and gene expression programming to identify the relationship between foreign contents and these two parameters. We validated our finding by using another set of samples, and we found that the relationship is very close to reality, and this method can be used as an alternative and quick technique to measure foreign contents instead of using the HPLC. Eventually, this method, as you can see, it's you can get your results instantly. So it takes only a few minutes to get the results. You have to just extract these parameters and feed it to the expert system or the fuzzy logic software to get the foreign contents. Our intention is to automate this process. So inside the software here, we can extract these parameters and feed it directly to the software, so you can get your foreign contents directly on the monitor. The second advantage of this technique over the current technique is all of this setup costs around $4,000 only. However, the HPLC costs around more than $70,000. There is no running cost here, and no expert person is needed to perform the test or to find the foreign contents. However, in the other method, we need expert person. We have to send our the oil samples to external lab to measure it, and it costs around, as I heard, $120 to $150 per sample, and it takes at least 3 days to get the foreign contents. This is the fuzzy logic we have developed to estimate the foreign content in oil samples based on the parameters of the spectral response, the bandwidth and maximum absorbance. As you can see here, we developed membership functions for the input variable bandwidth. We have 10 membership functions, and also 10 membership functions for the maximum peak. And you can see here the foreign content output ranges from new oil to scrapped oil, 15 ppm. You can see here we have developed 100 rules to correlate the input and output parameters, and you can see all of these rules here through this diagram, where you can change any of the input. Like, for example, if I want to change the bandwidth to 340 nanometer and the maximum peak to 1.45, I will get foreign content of 0.01, which means we have new oil. If I change, on the other side, if I change this to 400, for example, 31, and the corresponding peak of course increase to, let us say, 1.8, the output will change to 7 ppm. You can also determine this through the surface graph here, three-dimensional graph relating the three parameters: maximum absorbance, bandwidth, and foreign content. So you can get also it. To make it easy for the user, we developed it in Simulink. So if we go to Simulink here, you can easily enter your parameters here, and you will get directly your output here. We got these graphs here. As you can see, the good correlation between spectral response parameters and foreign contents. That's new oil here, which has the lowest bandwidth and the lowest maximum absorbance, followed by other oil samples with 0.5 ppm and so on until 15 ppm. What we did in our software, we extracted the bandwidth here and the maximum absorbance, and then those parameters are fed to the software, fuzzy logic software, to estimate the foreign content. These are samples of our model output. This is the measured value of foreign using HPLC, and this is what the model gives us. And you can see in this column here the error between the measured value and the model value. The error is very small, as you can see here.
One of the important aspects of this foreign estimation method using UV spectrophotometry technique is to ensure that the tests that is carried out are not dependent on the contamination that might be otherwise present in the oil. We have to ensure that those factors are taken care of. Also, it is important for us to demonstrate the consistency of furan estimation and correlate them with the HPLC or the gel chromatography technique. So in our development process, we have had approximately 50 samples from operating transformers in real life that ranges from new to approximately 50 years of age. That basically covers almost the entire range that would lead to a DP value from close to new to almost end of the paper life. I think you can see some of the samples that we have used already on the table.